Today we're going to do maths lesson for Thursday. So if you have not done this yet and you would rather do it with me, then don't forget that I am doing at 10 o'clock a live lesson of these pages. So if you'd rather be able to ask questions and get some help and do it with the class, we usually finish in 30 to 45 minutes every day, and then you'll be done with math for the day. So I'm doing that on Wednesday and Thursday at 10 a.m. every week. Today, we are doing a couple more pages in our practice and problem solving book. So you guys do not have these books. These are the purple homework pages that we used to do when we were back at school. So you can do this either by printing out the pages I sent your parents, or you can do it on Nearpod. If you go to Nearpod, I'm actually in a session right now, if you exit. And if you put in a code right where there's a little box, for me it says this, but if we go to log out, and if I go to here, it says join a lesson, you just enter the code that I have for you guys in there to join the lesson. Okay, but today we are doing some of these pages. We're gonna do page 377, 378, 379, and 380. So if you do not have a printer or Nearpod, if you're not sure how to access Nearpod, you can also just write the answers on a piece of paper as we go through it. So you can just write for number 1, draw, or write the answer that we do together. So let's start by taking a look at the example. It says draw all the lines of symmetry for each star shape. How many lines of symmetry does each shape have? Where do all the lines of symmetry cross? So the picture has all the lines of symmetry drawn for us, but where do all the lines cross? Do you see these dots in the center of each shape? The lines of symmetry are all crossing each other at a center point in the middle of that shape. So that's kind of interesting. That's a pattern that we're going to notice. Number 1 says draw all the lines of symmetry on the tree shape below. If you're using a paper, just draw this shape the best you can on your paper and draw all the lines of symmetry. I'd like you to try to do this now. Remember, a line of symmetry cuts a shape exactly in half. They can be diagonal, vertical, or horizontal. And when you were to, if you were to fold that shape along your line of symmetry, all of the edges should line up. So a line of symmetry on this envelope could be vertical if I folded it like this. Here would be my line of symmetry where that crease is. I fold it, all the sides line up perfect. There's nothing sticking out. I could also fold it like this. Call this like hot dog and hamburger in class, right? So be the hot dog. So this also, all the edges line up, right? So here at this center fold, a little glare so you can't see, but there's a fold here, there's a crease, and that would be the line of symmetry, which cuts the shape in half. I could not have a diagonal line of symmetry on a rectangle. That doesn't work. I'll show you why. Because the corners stick out, right? You see how this part is sticking out and this part are sticking out? The only folded part that's overlapping is here on this side here, so a small triangle. The rest is sticking out, so that would not be a line of symmetry. So imagine we cut this shape out and tried to fold it. Where could we fold it so that all the edges would line up? Which way? I believe that there is only one line of symmetry in this shape, and it is a vertical or up and down line of symmetry. I just learned how to do that. I can move my lines now. So at this line, if you folded the shape, all of those corners would line up, and that's what we're looking for. You could not do a line like this. That would not work if you tried to do that, because the top part would fold over, but it wouldn't cover this wide area. So that would not work. You could not do that. They wouldn't line up. So there's only one, I believe. So we're gonna just say 1. Number 2 says draw all the lines of symmetry on the X shape below. So I want you to do this, pause the video, and draw all the lines of symmetry you see on this shape. What I always look for is I look to see if both sides are the same, if they have the same indents, and then I see what I can cut in half. What I mean by cut in half is that these two lines are parallel and they're equal. So when I cut equal sides in half, that means both sides the same length. So when we fold them, they're gonna line up, they're the same length. So I know that I can cut this in half, that would fold here. I'm gonna have to move that. There we go. Did you find any more? There's more that we can do here. We can line up the angles and sometimes cut those angles in half if the two sides are the same. In this case, all this pattern is just reflected. You'll learn that when we're learning about graphs in future grades. So this pattern is really just reflected across those lines. It's the same thing. 1, 2, 3, 5, 6, 7, really 8 times. So how many lines of symmetry did I just draw? How many did you say? There are 4 lines of symmetry. So if you had less than 4, add the ones that I drew. You need to pause here. And let's go to the other side. 3, draw all the lines of symmetry on each pentagon below. Write how many lines of symmetry each pentagon has. So I want you to try to draw all the lines of symmetry now. Please pause and draw all the lines of symmetry you see. All right, so this is a pentagon, or they both are pentagons. Right away, I noticed something. I noticed that all the sides and all the angles are the same. So the more that's the same in a shape, the more lines of symmetry there are going to be. Let me show you what I mean. So the angles are all, I think they're obtuse. Let me grab my 90-degree angle and line it up. Yes, they are wider than this envelope, so that means it's wider than 90 degrees. So they're all obtuse angles, and all the sides are the same length. So I'm going to see what's across from each other. An angle is across from a side. So there's no parallel sides. So I'm not going to be cutting the parallel sides in half, but I am going to take that angle and break it in half along with the side that it is across from. And we're going to do this for every pair of angle and side that are across from each other. So let's look at this other angle. It's across from this side. And I want you to tell me, where are all of these lines meeting up? Where do they all cross? They all cross in the middle of the shape, just like on our examples. I told you this is going to be a pattern we see. So I just drew 1, 2, 3, 4 lines. Oh, I'm missing one. There's an angle there. I hope you knew that already and are yelling at me. Good. So there are 5 lines of symmetry. If you said less than 5, please add a couple more till you get to 5. And I believe those are the only lines of symmetry. If you think I'm wrong, you can comment or let me know. Let's look at the next pentagon. If you haven't done it already, pause the video and do this on your own before listening. So this one's a little different. All the sides are not equal and all the angles are not equal. I can see this is a right angle, this is a right angle, that's an obtuse angle. The top angle is obtuse as well. But I still notice that the left and right are the same. I see that I could put a line of symmetry here vertically. Do you see any more? I don't see any more lines of symmetry. I think that that is the only one. All right, let's go down to number 4. So notice on number 3 that the one with equal sides and equal angles had a lot more lines of symmetry, right? There were also a lot of sides and angles. The more sides and angles that are equal, the more lines of symmetry there will be. This pentagon did not have that many equal sides or angles, right? So it only had one line of symmetry. It had some equal sides, right? These are equal parallel sides, these are equal sides, but the angles were different. There was obtuse angles and right angles on that pentagon. Number 4, Titus drew a hexagon with 6 lines of symmetry. He says that all hexagons have 6 lines of symmetry. Use words and drawings to why Titus's thinking is incorrect. So a hexagon is a shape with 6 sides. I want to look back for a second at our pentagon. That was a shape with 5 sides, 5 equal sides. And how many lines of symmetry did it have? Do you remember? Hopefully it's on your paper. It was 5. So this works for all shapes. If all the sides are equal and all the angles are equal, however many sides and angles there are, that's how many lines of symmetry there are. That only works if the sides and the angles are equal though. Let me show you an example with the shape of number 3 with a pentagon. So if we had a pentagon like this one, is there 5 lines of symmetry? No. So it doesn't always have 5 lines of symmetry. It only has 5 lines of symmetry if the sides are equal. Okay, so let's go back to 4. Titus drew a hexagon with 6 lines of symmetry. He says that all hexagons have 6 lines of symmetry. Use words and a drawing to explain why he is incorrect. So I think we should start by doing a drawing so then we can explain the drawing using words. So what you need to do is draw a hexagon that has less or more, but it's not going to be more, less than 6 lines of symmetry. So I want you to do that now. Pause the video. Try to draw a shape that has 6 sides. It just needs to have 6 straight sides. That's all it means to be a hexagon. Nothing special. The sides need to all connect. So draw a hexagon that has less than 6 lines of symmetry. Pause the video and do that now. So to do this, you're going to have not a lot of equal sides, so sides of different length, and you're going to want to have not a lot of equal angles. So we're going to draw a hexagon. I'm actually expecting for this to be a little difficult. So 6 sides, so 1, 2, 3, 4, 5, 6. So that is technically a hexagon. It doesn't look like the normal hexagons that we see a lot of times in our book. So it doesn't necessarily have to have equal sides. You might have thought that before, but it does not. The sides may be different. So I'm just looking it up now. The definition says, in geometry, a hexagon can be defined as a polygon with 6 sides. 6 sides, 6 vertices, and 6 angles. So that's all it really takes to be a hexagon. So when you think about it that way, you could draw some really different looking hexagons that maybe with some right angles. 1, 2, 3, 4, 5, 6. I'll just make that a little longer. So that would technically be a hexagon. That's not really what I would think of. Now, a regular hexagon, we call regular, labels it as a 6-sided hexagon that looks more like this, but usually with equal sides. But how many lines of symmetry do my hexagons have? Yours might be different, that's fine. As long as it has 6 sides that connect, you're good. I have 1, 2, would that be a line of symmetry? No. I have 2 lines of symmetry. So it does not have 6 lines of symmetry, showing that T2 is incorrect. This shape has 0 lines of symmetry because this is smaller than that. So draw your shape. Does not have to look like mine. It might look completely different than mine. I can't wait to see on Nearpod and pictures of what your drawings are, because you can get creative with hexagons in ways that we don't usually see in our books. Then I just want you to explain kind of what I just explained and what we just talked about how hexagons that have 6 equal sides and equal angles will have 6 lines of symmetry, but hexagons that don't will have less lines of symmetry. So hexagons that have, you know what, I'm gonna say at the beginning, only hexagons that have 6 equal sides and 6 equal angles will have 6 lines of symmetry. Hexagons with less equal sides and angles will have less lines of symmetry, like the ones drawn above. So there I explained why he was wrong. I said he was wrong because yes, some hexagons have 6 lines of symmetry, but that's only the hexagons with 6 equal sides and 6 equal angles. Now, other hexagons, irregular hexagons is what we call them, with less equal sides and angles, like the ones I drew above, will have less lines of symmetry. And I might even go in and label that this one has 2 lines of symmetry, and then that this one has 1 line. Oh no, 0, I'm sorry. I don't know why it's wrong. 0 lines of symmetry. So that really explains everything. You need to pause, you can, but we're gonna move on to 5. Draw all the lines of symmetry that the design in each flag below has. Then write how many lines of symmetry that the design in each flag below has. So I want you to pause the video and do this on your own, and then I'm going to explain what I think. So the American flag's tough, right? Because could we go this way? No. No, it's a rectangle. So rectangles don't have diagonal lines of symmetry. They don't fold correctly, like I kind of showed with the envelope. And we can't go this way, right? Because there's stars on this side and not on that side. And we can't go this way because there's stars on this side and not on that side. So I'm gonna have to say 0. You disagree, let me know. Canadian flag, I can see that this leaf can be cut in half. So I'm gonna grab my line of symmetry and just put it right in the center of that leaf, cut the whole stem in half. But I can't go that way because there's a stem at the bottom and a leaf up top. So I think that's the only one. So this one just has 1 line of symmetry. I hope you got the same. Let's go to our last 2 pages. Which figure below shows a correct line of symmetry? Circle the letter for all that apply. So I want you to look at each shape, that's what I'm doing right now, and picture folding the shapes. And I want you to notice in the question what it says. It says, circle the letter for all that apply. All that apply. What does that mean? That means more than one answer. Which I'm glad, because when I was scanning through the options, I noticed there was more than one answer. I hope you did too. So go ahead and answer or take your best shot now, and then I'm going to explain each one. So let's look at A. Ovals are tricky. Ovals only have 2 lines of symmetry, and that's going to be going this way, and then also going this way. They do not have a diagonal line of symmetry. Think like rectangle. Just like a rectangle and oval, when you fold it, there's going to be a little rounded part sticking out on the bottom and on the top. This part's going to be over here. It's not going to line up over there. So A is wrong. That can be hard to see sometimes, but it is going to be wrong. Let's look at B. So on B, I want you to look at this point. If this point were to fold over that line and go exactly across, it would be like right there. So it's not going to line up with there or there like it's supposed to. So that is not a line of symmetry either. B is wrong. Sorry, no circle. It's going to be wrong. Now let's look at C. C, could we fold that in half? It looks like this line would line up with that line. They're the same distance apart from the line of symmetry. Looks like these two lines would line up with those two. That would work. So C is going to be correct. That's the only line of symmetry for that shape, but that is correct. And then let's look at D. D is an arrow. Are the top and bottom the exact same? If you fold them, are all of the lines going to line up? It looks that way. So again, if you ever want to try this, definitely feel free to cut out some of these shapes and do it at home. I'm going to clear these, so pause if you need extra time. Part 2. Number 2. Part of a figure is shown below. Line X is the line of symmetry for the completed figure. What does the completed figure look like? So this is kind of like when you're making a card, maybe for Valentine's Day, and you cut out just half a heart when it's folded, and then when you open it, the full heart shows up. And I guess by saying that, I just kind of gave away the answer. But sometimes these are hard to understand, so I want to give you a reference of maybe something you've done before. Picture folding that, or maybe you've done it with a snowflake. You fold the paper so many times, so then when you open it, it's a beautiful snowflake with all these patterns. The secret is symmetry. Honestly, those are all lines of symmetry. The same pattern is reflecting over all of those times you're folding it. The folds are the lines of symmetry. So next time we do a snowflake, if you've ever made one of those with scissors, cut it out of white paper, it's really just a lot of lines of symmetry. Same with if you cut out half of a heart that's folded and a heart's come out. Now, if we were to basically draw this shape reflected on the other side, we would put, you see a line's curved like this, we put a line curved like this. Let me get my pencil. And then we see it goes in and down until it hits the point. So that's not the prettiest thing I've ever seen. The question is, what does the completed figure look like? So I think it means all together. So that would mean it would be A. Because part of the figure is shown, they want to know what the completed. So if that was a part, they want to know what that part is with the missing part together. So Lei chose C. She just said the missing part. She only showed what was going to be on the other side of the line. So she showed what figure, we'll use the same words they did in the problem. She showed what figure would be on the left side of, what did they call it, line X. She showed what figure would be on the left side. Oh no, I meant right side. She only showed part of the figure. She showed the part that would be on the right side. We wanted to show the completed figure, the whole figure. So pause this if you need to finish. We're going to move on to number 3. Number 3, draw all the lines of symmetry on the figure below. How many lines of symmetry are there? Please pause and try this one on your own. So I always look first to see if I can split it in half this way, this way, this way, and that way. Those are my first, 4. I always do that first. So I start with the vertical up and down. Could I do a line like this? Are both sides the same if I folded it? Yes. A lot of times just drawing that line makes it easier to picture each side folding. Now I'm going to try horizontal. Could I draw a line this way and fold it? Yes. The top and the bottom of that line are the same. If I folded them, the sides would line up. Now I'm going to look at my diagonals. Those are not going to line up. I see right away this is too short to match that, right? This is going to fold over here, and this is going to be all the way over here. So those are not going to line up, so my diagonals don't work. When one diagonal doesn't work, the other usually doesn't. So once I try one and it doesn't work, I know that I'm kind of out of luck. So this is 2 lines of symmetry. If you had less than 2, there's definitely 2. Maybe we can say lines of symmetry. Label our answer. I don't think there's any more. If you disagree, you can send me a message and let me know. Name a quadrilateral that always has the same number of lines of symmetry. Draw the shape and show the lines of symmetry. Explain why the number of lines of symmetry is always the same. So for this one, we want to come up with a really specific quadrilateral. The reason for that is because there's going to be less change, right? So for example, if I were to say a rectangle, well, a rectangle could have 4 sides that 2 of them are the same length and 2 of them are different lengths, like this. But we also know that a square is a rectangle, right? So this shape is going to have less lines of symmetry than this shape, this square, but they are both rectangles, right? So if we say rectangle, we would be incorrect because a rectangle doesn't always have the same number of lines of symmetry. I want you to think about this. What shape does always have the same number of lines of symmetry? I can think of 2. Actually, no, never mind. I can only think of 1. I wonder if there's any more. I'm gonna look up if there's any more after this video. Try to decide on one and write your answer and pause if you want to do yours first. I am going to tell you the only shape I can think of is a square that always has the same amount of lines of symmetry. Why? Because a square always has the same 4 angles, 4 right angles, and the same 4 sides, equal length. All sides are the same length. I can't think of any other shape that's the case, where the angles always have to be the same and the length of the sides always have to be the same. I was going to say a rhombus because the sides always have to be equal length, but the angles aren't always, like sometimes they're acute and sometimes they're right. So when a rhombus has a right angle, it's a square. And it's going to have more lines of symmetry than if it has an acute angle. Because usually rhombuses don't have lines of symmetry unless they're a square. So long story short, square is the only shape I can think of. You may be able to think of another. If there is another shape that always has the same number of lines of symmetry, please let me know. I would love to hear it. Okay, so why? It's kind of what I just explained to you. I'm sure you could explain in your own words as well. I'm going to say a square always has 4 lines of symmetry. This is always true because it has, I'm trying to think of another word besides always because I've said always a lot. I'm just going to get rid of it here. This is true because squares always have right angles, have all right angles, and all equal sides. So that's going to be my explanation for why my shape is correct. So just make sure you have drawn a shape. Make sure it's not a rectangle, because I already told you rectangles are right. And at least explain why you think you're right. This should really be at least 2 sentences. I'd like you to say how many lines of symmetry your shape has, and let's draw them on there. I will with my square. And I want you to explain why it always has that many lines of symmetry, not just the shape you drew, but any shape. Because for me, with any square, it's always going to have this many lines of symmetry. I promise. You can try it if you want. You can draw a square as long as it is a square, which means it has 4 equal sides and 4 right angles. It's going to have 4 lines of symmetry. You might even label your lines of symmetry. Check it out. So those are my 4 lines of symmetry. Sometimes it's hard to, you can't count the other side of the line, right? So it's only 4, it's not 8. All right, and that's the last one. So that is all the problems we have for Thursday, and you are all done with math for the week. Nice job, guys. Thanks for listening.